So welcome back to DevSecOps Talks with Paulina.
That's going to be you.
That's
Mattias.
me, Andrey, and Mattias.
I thought we discussed this in the beginning, like, how should we go? How should we go? But no, it didn't work.
Now
But
it's
the
clear
hardest
that
part is
Paulina
behind
stuff.
us.
Yeah,
we should practice this thing, but it's a good thing because that brings us to the topic, right?
Chaos.
Yeah, we're talking about chaos today.
Yeah.
That was a good one.
And we start with chaos. That's good, right?
So what are we gonna learn today? What is chaos?
Yeah.
What is chaos engineering? Why do we do it? Why does it matter? Who should do it in their cases, and where should you do it? So we have a few questions to answer.
Yeah, so many questions. Like first, like why? Why is it called chaos? Did it call like chaos monkey? What's the monkey coming from?
It started from Chaos Monkey, which is introduced in 2011 by Netflix. And the idea was that Chaos Monkey is randomly killing servers in Netflix production to cause incidents which teams need to fix and to increase reliability within their production environments. Have you heard about it before?
Yeah, I think so. I think I heard about chaos monkey. And you hear the term like chaos, that you have something that goes in your production or test environment and do things that can happen, and you want to test the resilience of the system in that way. Right?
I do that all the time. Like I find the server, which I don't recognize, like what is this? And I kill it. And then I wait for someone to come screaming. I do that all the time.
So you're doing so well-known scream test. Turn off something and see if anyone screams.
Yeah, exactly.
Yeah. But it's so the more or less taking that approach and make like a way of working with it. Like you break things on a regular basis to see that your system can handle outreach. Isn't it also something that comes with like microservices approach?
Yeah, you can also use it into microservices. But let's finish about where is it come from. So after Netflix, we started introducing it more in more big companies like Google, AWS, Microsoft, LinkedIn. So bigger players on the market starting to apply it as well. After some time, we got it not only killing the servers, but it got extended by a tool called SimianArmy, which added also failures of a network, CPU spikes, DTU centers, outreach, and it wasn't 2011, it was 2021 where we seen AWS fault injections, so we can do control chaos engineering in cloud as well, where more and more companies are these days based. But we have a few misconceptions. Yeah,
you can also do them like network traffic, right? I think I remember correctly, I did see it with like some of the service mesh that is called Cilium, and they actually was able to also inject like a third of the traffic, returning 500 to test like the resilience of services, right?
I think it's like one of the, because I have a pre-configured experiment that you can run.
Yeah.
And I think one of the easiest that you could do, and most probably your infrastructure would be ready for, is outage of the availability zone. So you could
exactly
shut down the availability zone. Technically, you shut down the traffic in availability zone, and then your database is supposed to fail over to another AZ. You have the scaling groups, your containers, what have you. And interestingly enough, you can actually see what's going on. So they would inject, I think it's network access list rules into your VPC. So they would like go check what VPC you have and inject network access list rules blocking all the traffic. In that AZ.
So why? What's the purpose? What do you say, Paulina? What's the purpose of doing all this, right?
So purpose is to increase confidence and reliability of the system in the real world system. So the system should be ideally production, but as close as possible to production, because some systems you cannot turn off if it's, for example, you have cloud-based emergency services or something. You cannot do this in production there. So it's gonna vary depending on what your system is doing. So that's the main idea to testing on the live system. And expose the weaknesses which we cannot find on our own as well by mitigating chaos engineering and incidents.
Let's stay on the history for a little bit longer and the reasons why people do it, because I would argue that technically you could do chaos engineering maybe without calling it so on AWS even before you got fault injection service available. So if you ever used EC2 spot instances, that would be your perfect testing. Those allows you to bid for the cheaper instances. If someone is bidding higher than you, those instances will be pulled under you. You will get interruption signal, so then you're supposed to be rescheduling your services from the instances that will be taken over. So if you ever run on EC2 spot instances, you would already doing chaos engineering. That's like one thing. There are actually tools that integrate with that. So for instance, if you're running Kubernetes, God forbid, there are tools that allows you to basically receive those interruption signals and cordon the nodes that are about to be terminated and then evict pods. So your service is getting rescheduled on other nodes, and when the node goes down, when it's pulled under you, you have no containers running there and you have no interactions. So that's like a good way of building resilient systems and testing that it can sustain a failure. And you don't need to do containers, so you can start with EC2 and autoscaling groups, meaning that when they pull the instance under you after scaling group, technically could try to provision another one, because there could be a cheaper instance as another vulnerability zone, and it's possible to configure after scaling groups this way. Plus, I would even argue you should be doing that, not for the sake of doing chaos engineering and improving your resilience and disaster recovery, but also in terms of security. So with some customers, what we do, if they run EC2 instances, we would rebuild those EC2 instances using Packer each week, and then we will replace existing instances with new instances just to refresh all your infrastructure. The primary goal here is that's automated way of doing patching in immutable infrastructure mode, if you like. So plus we discarding any configuration depth accumulated there, because opposite of not doing this. So for instance, you're not doing chaos engineering, you're doing immutable infrastructure, which I think you should. You would get with servers that are like snowflakes and everyone is very afraid of touching. And if those servers go down, there is no recourse. So it's very hard to recover because no one have any idea of how they got configured or how they came to be this way. So immutable infrastructure goes hand in hand with chaos engineering. So if you're thinking about doing that, so maybe saying immutable infrastructure first, then self-healing infrastructure, and then start experimentation.
So I think we have later on in plan to discuss when are you ready for doing the chaos engineering, but also as you're right, I think it didn't start from Chaos Monkey. It started before, but it wasn't called this way. And you can do it in pieces and in more controlled way if you're not ready to let it go and do stuff on its own, more uncontrollable, more random.
But should it always be like random? I mean, you have this misconception here, like that chaos engineering is something that you shouldn't do, and it's like a more tested approach of testing a chaos. I mean, it's like the opposite. Like the chaos is just things going down all the time, but actually it's more, you see it as a more structured way of killing things. I mean, when we talk about faulting,
where are you doing it, when are you doing it, and what do you wanna, for example, to kill, and on what environment. So you can be able to, give it as big playground as you want.
As you want, yeah.
So one thing that we haven't mentioned just yet is the fact that, the chaos engineering is not about running around killing servers, right? So it's learning and validating your assumptions about system behavior under load and stress. So usually the way it works, you would do assumption. So you do a hypothesis saying, I believe we're going to be fine if one of 3 availability zone goes down. That's your hypothesis. And then chaos engineering is basically a discipline that allows you to test those hypotheses. That gives you tools and approaches that would let you to validate your hypothesis. And it might be so that your hypothesis is incorrect. So you're saying, I can sustain loss of availability zone. You run the experiment, maybe in different stage, and then you realize you cannot. Then what Netflix was doing, I think, they took it to the next level where they started to run it continuously in production. So that would be very similar to running on spot instances. And if you have no state, technically you could do that. Even with a stateful workload, you get a notice of 2 minutes from the spot instances. So you could do that, but there is a road to get there. And if you are to start somewhere, you need to start from defining your hypothesis and what you want to prove or disprove. I think that's a good place to start.
But isn't that like where I see it? Like if you run stateless application, right, and you run them, maybe we come to it when you're ready. But for me, if you run stateless and you run multiple applications that you can do when they're stateless, there's no problem killing them all the time because they're stateless. A new one come up, and you always have a decent number of them running. But when you come to stateless applications, like as you said before, like your main database, killing that one or shutting that down and making sure that things move over to the slave, that's something that will be very more bravely people would do that.
But look,
killing and
even stateless is still an assumption and hypothesis that you need to test. You think you're going to be fine until you realize you have, like, if you're running like Kubernetes, you have like a replica set or whatever it's called, deployment with only one pod configured. So it's not configured to autoscale, and you kill that one, and everything suddenly goes down. Yes, it's stateless. It's kind of supposed to. It doesn't matter. You should be able to kill it, but your system configuration is so that it actually exists in a one single entity. Like, yesterday, I spoke to developers, and they were looking into the server that was periodically throwing 500s, and we were trying to figure out what that is. They were looking in all possible kinds of logs, like ELB logs, application logs, envoy logs, all possible kind of logs. And then suddenly we look at the resource configuration, and we see that thing runs at 1/4 of CPU. So those Fargate configuration. So it basically has 1/4 of CPU. And it has like 256 gigabyte of, maybe 512 gigabyte of memory, but very little resources. And after scaling policy set to scale when CPU at 75%, but by the time when it's at 75%, that thing is dead because it has only 1/4 of CPU. So this is like an assumption, like it's supposed to scale, right? But that is misconfigured. It doesn't have adequate resources. So,
but is this the only way to test these things? Would you say? Right? You have this assumption that you build your thing and you test it. Like, I mean, you have set your limits and resources on your deployment. But maybe chaos engineering is the only way you can test that these things actually work as they should.
Kan du säga till Vickes föräldrar att han är här?
You're leading somewhere with this question.
Yeah. Sorry, I have visitor coming in asking things. No, maybe chaos engineering is the only way to test these things. I mean, how else would you do it?
Just tell us, Paulina.
I mean, you have also traditional engineering next to it, yeah? So you can, depends what you want to test and how you want to test. You can test something in the static conditions when you can also test it in more dynamic. You can simulate certain tests, but somehow you want to try to have none of the other production going to be as close, as similar and close to how production looks like. None other environment going to be as close. You don't going to have the same traffic. The same data, the same load, you can simulate it, but it's not going to be real world conditions ever, even if you try to deploy the same code and so on.
Exactly. That's what I'm thinking. Like, you can do load tests, right? And then you see that pod scaling, you can test your load. But if you run your application in the Kubernetes cluster, nodes will go away. That's the nature of them, right? You're running Spot or anything like that. So you need also to test the load test with nodes going away, because that's the real scenario that the application lives in, right? If you don't test that, you're not testing it for the real action.
And you can combine both. I would argue you need to have both, because if you have a stale system like staging or development where you don't have traffic, you might kill something and it comes back, but you don't get enough signals to discover the issues. So you can run the load test and then start killing things under a load. And then the things could get interesting, because then you might discover actually more of issues failing, since you will introduce delays into the system because of all the traffic it needs to handle.
Yeah.
And also usually dev or staging are running on the smaller instances compared to production, which has the bigger load. And because of the cost, very often they are also scaled down because it's quite expensive to have as big environments, especially for bigger systems as production.
I think
this is interesting. And also I see like more and more companies are asking for like resilience, availability, things need to be up. Isn't this one of the things that I mean, do you see a lot of, you're doing more consultants, do you see companies doing this, like testing the resilience of the application in this way? Or
I
is
think,
it just like,
from my experience, most places are not mature enough to be able to implement it. If you struggle with basics, you need to take a step back and not do chaos engineering and fix your basics. From my own experience, most organizations are not mature enough to be able to do it on the extensive way. Maybe sometimes they do it on the narrow down spectrum, so they test particular part of the system within more chaotical way, or they trigger incident on the particular timeline, on the particular environment. But no, I haven't seen this broadly used because of lack of maturity. I don't know what's your experience, Andrey, as you're also in consulting.
I should say that we don't really see it very often, if at all. So we see the different way of chaos engineering that I described before, right? So running on EC2 Spot instances and doing things Amazon way, so like running up the scaling group so the system is elastic and it could self-heal. If you are at that place, that like for instance you build, if you're running servers in 2025, like EC2 instances, well, you should definitely build them with Packer or like some other tools that allows you to create the golden images, and then have them in after scaling group and what is lunch template it's called nowadays. So if the instance is taking out of service, it's possible to replace it without waiting for your provisioning tool to log into the instance and drop all the packages there. So like no Ansible stuff, please. That will already give you a good enough baseline.
Yeah, I also seen some observability where you have, certain triggers or, monitoring of the application. And if there's particular action, then it's you have particular action to fix this automatically done by the system. So I don't know if coming with auto-scaling application is down, it's gonna kill the container or Kubernetes or whatever and restart it. Some simpler ways of doing it, or.
But Paulina, do you see that this feels like when we talk about observability, we talk about different things, and we say like, well, tracing is the one that everybody should do, but it's the hardest part, right? And it usually come like the last, right? It feels for me like Chaos Monkey is that as well, but in testing. That's the test that you need to do, but it's the hardest to do. That's why people do it like last. Isn't it better to skip load test and other things and just go for the chaos test early in the process? How do you say about that?
All based on my own experience and research that I've done regarding this, everyone was recommending it once you have basics covered. Then you should go to chaos engineering. You need to be mature enough to be able to get profits of it, because if you don't have basics covered, you don't really need to look for hidden issues in the system. If you have issues visible with your eye in every corner. So fix what you can before you can get to this level.
It requires time, so you need to justify to the business why you're going to spend your time on it. And if you are to go through certain certifications, like SOC 2, for instance, right? There you need to show your disaster recovery planning. And that might be part of it. So instead of doing BS exercises and ton of paperwork, you could take the same time spent on the BS exercises and the paperwork and put that time into building some kind of fault simulation environment.
Yeah.
And that will be your disaster recovery strategy. So you can show to people that it's there, you're using it, you can automatically run it. And this is where you can actually, with confidence, tell to the business, give us this time to work on this. Because if stuff is burning left and right, you just don't have time on that. And that looks like a supplementary thing.
Yeah, so you can check a few basics, like if you have monitoring, is your management with you on it? Do you have some automated incident response? Do you do postmortems? Do you have observability? And also you can do it in the smaller ways if that's too many nodes for you. I mean, you can have a game day when you prepare certain incident and you mitigate it with your team on the particular day, and not in the production, but maybe on dev or test or completely new environment. So you can do it in the smaller scale if you cannot do it if you're not ready to do it on the across whole system, and also go step by step with it. You don't need to cover whole system from scratch. You can do it start from servers or your compute, and then check your databases or network and so on.
I think we might be covering like enough for the first part, because Paulina prepared really well. If you're watching it live on YouTube, you could actually see the Mira board with all the stickers that Paulina prepared. So there is much more to discuss, and we're probably gonna split it into two parts. Stop around here and pick it up with more actual things that you could be doing next time.
Yeah,
because we have like a lot of tools mentioned here. If you're not watching, if you're just listening, don't worry. because we're gonna go through all those tickets in the next episode.
Yeah, and Paulina, do you want to give some headlights what you have written on these tables, so you can see what's coming in the next episode? You have
so for next one, we want to cover more how do we do it in practice, and so we discuss what is it and why it's important and what does it mean to be ready for it. But next step is, okay, where should you do it? How do you do it in practice? What is required to be able to do it? And what outcome you can expect from it.
If you want to learn what is Pumba Docker container, the next episode is for you. Stay tuned.
Yeah, that as well. And with that, thanks for watching on YouTube and listening on the podcast.
Thank you very much.
Bye-bye.
Thank you.
You have been listened to DevSecOps Talks with Mattias, Andrey, and Paulina. For notes and information, please visit devsecops.fm. Thanks for tuning in.